Good night, everyone, and welcome back to Fundamentals of Engineering with Farhad. Geotechnical Engineering Part A Soil Mechanics. Consolidation settlement in soil under a foundation. So, if we have a foundation, we want to calculate S sub C, which stands for consolidation settlement in soil. So, assume we have a foundation and a soil beneath, like sand, like in our case, sand medium dense under our foundation, and a axial load of P, like a column force applied to the foundations, move to the ground. We want to observe the behavior of the soil beneath the foundation. So assume we have like two identical cases with the same uh, in terms of foundation and loading, but different in soil type. Assume both of them are in saturated soil. Case 1 is in a medium dense sand, and case 2 is in a lean clay lightly over consolidated. And the same axial load applies to both foundations. So let's jump to our multiple choice question. In the figure, you will see two identical building footing handling similar axial force of P, but they are located in different soil type. We want to know which of the following statements is the most correct one. In order to observe the settlement behavior of soil, first let's see what's the conceptual meaning of consolidation. So this is our case 1 and case 2, like in different soil types. So in consolidation, for example, if this is a whole body diagram of a soil sample and we apply distributed load, for example, over the soil, and our saturated soil layer consists of two components, soil grain and also pore water inside the soil. So if you see what's happening inside the consolidation process, so when you apply a force over a saturated soil layer, delta sigma, the total stress initially goes to the water, and delta U increases. And over time, delta U disappeared and delta sigma prime comes to life. So one can say delta sigma, the total stress initially goes to the water, and in long term it just moves from the water to the soil grains. That's effective stress in soil. And what's happened for consolidation here in gravel and sand, which have like a high permeability and also conductivity, it just says there is a immediate settlement happens in gravel and sand like in grain soils, but in like soil like high plasticity like clay, hydraulic conductivity is low, permeability is low, and it just takes a while to consolidate the soil. So that's why for gravel and sandy soil we have like immediate settlement, and in clay we will see a consolidation happens. So one can say that's what exactly we are looking for, S sub C. So one can say the schematic of a diagram of soil in terms of carrying the load initially, the distributed loads goes to the water, and over a time it just moves from the water to the grain of soil. So in that sense, one can say consolidation is a reduction in volume due to increase of stress in a saturated soil with low permeability, which refers to the soil like clay, which ends up in a drainage of poor water between soil grains and then a reduction in thickness of soil layer. We call it like consolidation settlement S sub C. So by the information provided, we can easily see in sand soil, sandy soil, we have like immediate settlement because hydraulic conductivity is high, so there is no such thing like a consolidation settlement. But in clay soils, what's happened due to low hydraulic conductivity and low permeability, consolidation over times happens. So if we talk about the long-term settlement, the long term only happens in more pronounced in clay soil. So the long-term settlement for case 2 is more than case 1, and that's obvious correct answer. So that's our correct answer. And if you want to double check the long-term settlement for sand is less than case 1, case 2 is less than, sorry, for clay is less than sand, that's wrong. The long-term settlement are the same for both. No, that's not the same. Settlement is not a concept for either case. No, it's not. It's not. That's not also correct. It's the settlement is a concept for both of them, but for the sandy soil we have like immediate settlement, no long-term, and for a clay soil we have like consolidation settlement. Thank you. We'll solve more problems in geotechnical engineering.